Now we are going to understand if we are implementing error detection or correction techniques, what specifically do we require out of the data link layer? Specifically, what strategy are we going to apply to detect and possibly correct errors? In this module, we shall start with identifying the strategy. Then we'd also look at the capability of the strategy that we've chosen, and we are going to understand the limitations or the constraints there is as well. The references that I've chosen are, the first are the lecture notes on the given URL. The second is the book, The Complete Guide to Networking and Network Plus by Michael Graves. Let's look at the strategy that you plan to implement. We are interested in sending raw data from the sender side to the receiver side. But since we are interested in knowing exactly if our data bits are sent correctly and are also received correctly and are processed accordingly, we look at the sender side. We take k bits of data. These data bits are passed on to something called a generator. This generator ensures that for these k data bits, some additional redundant bits are generated, forming a total of k plus r equal to n bits, which we call the code word because our plain data has now been codified. It is sent on to an unreliable communication channel because, as we talked about the communication medium before, the communication channel does make errors and it flips ones into zeros and zeros into ones. On the receiver side, the code word is received. Now, we are not sure if these n bits and these n bits are exactly the same. In order to verify that, we need to incorporate something called a checker, or in other words, some kind of processing that must take place on the receiver side. Once it has been verified by the checker that the data which has been received is correct, it would be subsequently passed on to the upper layer. So the k data bits sent have now been successfully received on the receiver side because our error detection mechanism said that all the data sent is all right. Another way of looking at it is in terms of layering. We take data from the network layer, and data at the network layer is called an IP datagram. We add the header of the data link layer to it. Then we perform some kind of generator function and we code the error detection bits to it. These error detection bits become part of the data stream that is sent from the sender to the receiver. On the receiver side, again, a check is performed if all the data bits have been received correctly. If there is a problem, it is discarded, else it is passed on to the upper layer, that is the network layer of the receiving side. You may appreciate that the data bits that are sent and the data bits that are received may be the same, but the redundant or parity bits that you added may not be the same as in here. So it may be possible that the data that was sent is not an error, but the redundant bits that were sent were an error. If that's the case, it means that the receiver is still going to show an error. The capability of error detection and error correction can be represented in terms of Hamming distance. For example, if you look at these two numbers, 1111 and 1001, if you look at these two bit streams, you appreciate that two of these bits are different and the first one and the last one are the same. What does it mean? It means that the Hamming distance between these two is equal to 2. So if we know the Hamming distance between two code words, we can exactly determine that once the parity bits have been added to our data bits, how much different does the newly formed data bits appended with parity bits is from the original data. Depending upon its distance, we can say that given we have an error ed it is going to be detected if the distance, Hamming distance of the coded data -1 is at least one more than the bits which are in error. In simple words, if error happens and the error is not very grave to flip a very large number of bits as compared to the strength of that error detection scheme, it would be detected. When we talk about error correction, the error correction requires an additional constraint, that is the distance of the codified word from the original uncoded word -1 divided by 2 has to be at least one more than the number of bits which need to be corrected. It means that the Hamming distance is central to identifying the strength of the error detection or error correction algorithms. In summary, we can say that all error detection and error correction methods work as long as the error is below a certain threshold. The choice of the error detection or error correction mechanism determines the level of threshold. If we were to allow any number of bits to go in error, either in data part or in the redundant parity bits, then no error detection or error correction mechanism can work, no matter how advanced or how complex that may be. And why is that? Because any valid pattern can transform into any other valid pattern, and the receiver is not going to make a distinction or can distinguish between the errors which have gone wrong, the errors that have taken place.